This video is going to go through a practice problem using the quadratic formula. There will be 3 videos like this. Each one will do an individual practice problem that you can use to check and make sure you understand how to use the quadratic formula to solve an equation, solve a quadratic. Or when we say solve in class, remember we mean find the x-intercepts. Also remember, if I said find the roots, that means find the x-intercepts. If we say solve, it means find the x-intercepts. If we say find the zeros, it means find the x-intercepts. And over here in your flipbook, you can see I used all of those words, so you can hopefully begin to remember that all of those questions mean to find the x-intercepts of the parabola. So let's go ahead and start our first practice problem. You can number this on your paper, practice problem number 1. And let's say that we had the quadratic equation that was y equals x squared minus 12x plus 36. Now, again, I would advise class, you go ahead now and stop the video. Go back to the notes or the flipbook section that shows you how to use the quadratic formula in section, I believe it is section number 3. Let me check that. Yes, it is section number 3. Pause the video, try to solve this, then start the video back up again and see if your solution is correct. So pause now. Okay, hopefully you have attempted to solve this problem. I'm going to follow right along with the steps in our flipbook, and you will find again, class, as you practice these, that you can take some shortcuts to get to the answer, but be careful. I'll be pointing out to you where most students will make mistakes when using the quadratic formula. Okay, the first step we always have to do, class, we have to set the equation equal to 0. So y has to be 0. Everything has to be on one side of the equal sign, and the other side has to be 0. So let's go ahead and write this equation. X squared minus 12x plus 36 is equal to y, which is 0. All I did was just flip the 2 sides around. At this point, we can identify a, b, and c. So I'm going to do that now. So in this case, a is equal to 1. B is equal to negative 12, and C is equal to 36. Now I'm going to point out to you right now, class, most students will make a mistake when using quadratic formula because they will not write down A, B, and C, which means they won't write down that B is negative 12, and you'll see in the equation we flip the sign, and they'll forget to flip the sign, and their answer will be wrong. So there's our A, B, and C. As I went through the steps in the flipbook, I told you that I think the best option for you to be successful is to find the discriminant first. And the discriminant is b squared minus 4ac. And if you look at the quadratic formula, you will see the discriminant is the part inside the square root. So if we solve that first, then our equation is not that difficult to handle. So b squared minus 4ac. Well, I'm going to write this exactly the way I would put it in my calculator. This is negative 12 squared minus 4 times a times c. Let's go ahead and put that in our calculator and see what we get. So we've got parenthesis negative 12 parenthesis squared minus 4 parenthesis 1 close parenthesis, which is times 1 times 36. Let's press equal, and you end up with the answer of 0. So our discriminant in this case is actually going to be equal to 0. I'll put a Okay, just see that I was going to put a circle around it, but it'll look just like the 0, so I'll just leave it like that. Alright, next step is, well, let's go ahead and write our x-intercepts or x-intercept values. So x is going to be, our x-intercepts are going to be equal to negative b plus or minus the square root of, well, we've already found our discriminant. It's going to be 0 over 2a. Now take a look at our b value. B is negative 12. That means in our quadratic formula it's going to change to positive 12 plus or minus the square root of 0 over 2 times a, which is 1. And so our final solution is going to be 12 plus or minus the square root of 0, and 2 times 1 is 2. So there are our x-intercepts. The next step I talk about in the flipbook is to go ahead and see if you can simplify the square root. So let's take a look. The square root of 0, we know if you put that in your calculator, you're going to get 0. So I'm going to write the word yes. This can be simplified. So that means when we write our final answer, we can just simplify the square root of 0 just to be 0. So our last step is our x values then are going to be equal to two values. In this case, it's going to be 12 plus 0 over 2, or 12 minus 0 over 2. And so we know, so x is going to be equal to, and you put this in your calculator, 12 plus 0 over 2 is going to be 6. And 12 minus 0 is also going to be 6. And you usually aren't going to write those two numbers, class. They're the same number. So in this case, we could just finish our answer right here and say, so x is equal to 6. That's it. Both of these fractions turned out to be the same because our discriminant was 0. Now, take a look back at our flipbook. You can see when the discriminant is 0, we have one real 0, or one real solution, or one real x-intercept. So class, if you think about this, we know this parabola is going to have the vertex right on the x-axis. It's going to be actually right at 6, x equals 6. And let's take a look at some more things real quick. The a value is positive. That means our parabola is going to be facing up. So just a little bit of information about the parabola itself. And if you want to put a little note here on the bottom, just so we learn this together, if the discriminant is 0, the number of x-intercepts, you know what, I should actually make this say the number of x-intercepts. Let's move that. When I put the number sign, doesn't mean hashtag. The number of x-intercepts equal 1. So there is a solution to our practice problem number 1. Our x-intercepts, or our solutions, are just 6. If you plug 6 into this equation, it will make it true, and it is the only x value that will make this equation equal to 0. Come back for the next video. We'll do the second problem using the quadratic formula.